Hi boys and girls, this is lecture 6.6, the topic Exponential Functions, Differentiation and Integration, Part 2. The fact that the exponential function is its own derivative makes integrating exponential functions equally straightforward. Let u be a differentiable function of x. Then the integral of e to the x dx is e to the x plus c, and the integral of e to the u du is equal to e to the u plus c. Now we should pay close attention when we're integrating e to the u, when u is actually a function of x. If that's so, we have to ensure that the complete du is in the integrand. This often requires some slight adjustments. Let's do a couple of examples. We're asked to integrate e to the 3x plus 1 dx, and let's note that u in this case is 3x plus 1, which means du is 3 dx. The dx is there, but the 3 isn't, so we will need to add it to the integrand, and we'll compensate for that by adding the coefficient 1/3 on the outside of the integrand. Now we have e to the u, and then of course the complete du is present as well, which means we can integrate. This becomes 1/3 e to the 3x plus 1 plus c. Let's look at our second example. U is equal to negative x squared, which means du is negative 2x dx. The x is there and the dx is there, but we need negative 2 instead of 5. And so I'm going to rewrite the integral, taking the 5 outside the integrand, and let's rewrite x e to the negative x squared dx. I'll insert the negative 2 and of course divide the 5 that's already out there by negative 2 to compensate for adding that negative 2 to the integrand. Now this is e to the u, and with negative 2x and dx, we have the complete du in the integrand. So this will be negative 5/2 e to the negative x squared plus c. Here we have two more examples. Find e to the 1 over x squared dx. Now before we wonder what to do with this x squared in the denominator, let's identify the u of the exponential function. In this case, u is 1 over x, which of course is x to the negative 1. That means du is negative 1 x to the negative 2, which can be written as negative 1 over x squared. Okay, now we see what that x squared is doing over there. It's actually du for 1 over x. So these two pieces together make the du. Of course, it should be negative, and so we need to insert the negative in the integrand and compensate for that by putting a negative on the outside. Now we have e to the u du in the integrand, and we can integrate. This is going to be negative e to the 1 over x plus c. Let's look at this second example. Once again, it does seem a little crowded in the integrand, but let's focus on the u. In this case, our u is cosine x. Du would be negative sine x dx, which is why we have sine x over here. It does need to be negative. Once again, we insert the negative and compensate by adding a negative to the outside of the integral. Now this is e to the u, and then these two pieces together make the du, so we can integrate. This is going to be negative e to the cosine x plus c, and that's your answer. Finding area bounded by exponential functions. In these two examples, we're going to evaluate these definite integrals, which will give us the area under the curve between the specified endpoints of integration. Let's examine this first integrand. It looks as though it could be a du over u pattern. If u is equal to 1 plus e to the x, then du is e to the x dx, which is exactly what we have in the numerator. So this is a du over u pattern, which means that our integral will be natural log. The natural log of u, which is 1 plus e to the x, and we'll be evaluating this from 0 to 1. This gives me natural log of 1 plus e to the 1 minus natural log of 1 plus e to the 0. That's natural log of 1 plus e minus natural log of 2, and that is approximately equal to 0.620. Now let's look at this second integral. First of all, I'm going to rewrite it. Negative 1 to 0 of cosine e to the x, and then I'm going to put after that e to the x dx, because now we can see that this is really just cosine of u, where my u is e to the x, and of course e to the x dx would be du. Well, the integral of cosine u is just sine of u, so that means I'm going to have sine of e to the x from negative 1 to 0. That results in sine of e to the 0 minus sine of e to the negative 1. Continuing to simplify, this means I have sine of 1 minus sine of 1 over e, and that is approximately equal to 0.482. That's it for today's lecture. I leave you with this depiction of another epic battle involving weapons of math destruction. God bless you, boys and girls.